The universe is composed of matter that constantly shifts its form through a molecular battle. This battle rages between thermal energy and the invisible, stubborn strength of chemical bonds. At the lowest energy level, solids maintain a rigid, vibrating structure within their confined space. These particles hold their positions, shivering in place as they resist the pull of entropy. In contrast, liquids allow particles to slide past one another in a graceful, fluid dance. They possess enough kinetic energy to break free from rigid constraints while remaining loosely connected. As heat increases, gases emerge with particles flying at high speeds through the open air. These molecules collide and ricochet, expanding to fill every available corner of their vast container. At extreme temperatures, matter enters the plasma state, a superhot soup of wild electrical particles. This ionized chaos fuels the stars, burning with a brilliance that defies the cold vacuum. This transition between states is governed by the gain or loss of vital kinetic energy. Energy dictates whether atoms lock into place or break free from their previous molecular bonds. Understanding these four states, solid, liquid, gas, and plasma, reveals the fundamental architecture of our world. This architecture supports everything from the ice in a glass to lightning in the sky. Matter is not static. It is a dynamic participant in a grand cosmic cycle of transformation. It is constantly responding to the shifting energy environment that surrounds it at every moment. The rigid crystalline lattice of a solid represents a temporary stillness in this chaotic universe. Yet, even within that stillness, the atoms hum with a quiet, persistent, and rhythmic vibration. When heat is introduced, the lattice begins to falter, losing its grip on the structure. The particles gain momentum, sliding past their neighbors in a fluid, ever-changing, and liquid state. This fluidity allows matter to take the shape of its vessel, adapting to new boundaries. As the temperature climbs higher, the liquid bonds snap entirely under the pressure of heat. The particles are liberated, transforming into a gas that moves with chaotic and frantic speed. They race through the atmosphere, invisible and energetic, carrying the weight of their own momentum. In the heart of a star, the energy becomes so intense that atoms shatter apart. Electrons are stripped away, leaving behind a glowing, ionized plasma that pulses with raw power. This state is the most energetic of all, dominating the vast, dark reaches of space. It is the fire that lights the cosmos and the force that binds the galaxies. Each state represents a different level of freedom for the particles within the material substance. The transition from solid to liquid requires a specific threshold of energy to overcome bonds. The transition from liquid to gas requires even more energy to achieve total molecular liberation. This cycle is the heartbeat of the physical world, driving every change we ever observe. We see the evidence in the melting of snow and the evaporation of morning dew. We see it in the condensation on a cold mirror and the freezing of lakes. Nature is a master of these transformations, constantly rearranging the building blocks of all existence. The molecular battle is never truly won, but it is always being fought with intensity. Thermal energy pushes against the bonds, seeking to expand, to move, and to break free. Chemical bonds pull back, seeking to maintain order, structure, and a sense of permanent form. This tension creates the diverse array of materials that we encounter in our daily lives. From the hardness of a diamond to the lightness of the air, everything is connected. The study of these states is the study of the fundamental laws governing our reality. It is a story written in the language of atoms, energy, and the void between. Every object we touch is a participant in this high-energy performance of nature's laws. The ice in your glass is a solid, holding its shape against the room's heat. The steam rising from your tea is a gas, escaping into the cool, open air. The lightning in the sky is plasma, a sudden, violent release of electrical potential energy. These are not separate phenomena, but different expressions of the same underlying physical truth. Matter is simply a chameleon, changing its appearance based on the energy it currently holds. By observing these changes, we learn to predict the behavior of the entire physical universe. We see the patterns in the chaos and the order within the swirling hot soup. The cosmic dance continues, indifferent to our gaze but essential to our very existence here. As we look deeper into the microscopic world, we find the same rules apply everywhere. The stars and the stones are made of the same fundamental, shifting and dancing matter. It is a beautiful, complex, and unending process of transformation that defines our entire reality. We are observers of this dance, learning the steps as we watch the atoms move. The universe is a stage, and matter is the performer in this grand cosmic play. Every shift in temperature is a cue, and every state change is a new scene. We are beginning to understand the script that nature has written for all of us. The dance goes on, forever shifting, forever changing, and forever bound by these simple laws. This is the architecture of everything, the foundation of the world we call our home. As matter continues its restless journey, phase changes occur when thermal energy is added or removed, forcing particles to skip or transition through these states in a complex, shifting molecular ballet. Adding heat triggers melting, vaporization, and the rare, sudden shortcut known as the process of sublimation, where solids turn directly into gas without ever passing through the intermediate liquid phase of matter. Conversely, removing heat leads to condensation, freezing, and the delicate process of deposition, where gases solidify, instantly transforming into intricate frost patterns that cling to the cold surface of a window pane. A fascinating phenomenon known as the Plateau Effect occurs during these critical shifts in physical state. As a substance changes phase, its temperature remains constant despite the continuous application of external heat. This happens because all incoming energy is dedicated to breaking or forming essential chemical bonds rather than raising the kinetic energy or the overall heat level of the substance itself. Whether it is steam rising from a boiling kettle or frost forming on a winter window pane, these microscopic molecular shifts are happening all around us in every single moment of time. By mastering these fundamental principles, we effectively decode the hidden mechanics of the physical world, proving that even the most mundane objects are part of an intricate, high-energy performance. Nature's fundamental laws orchestrate this dance, ensuring that matter remains a participant in the cycle, constantly evolving and responding to the energy environment that dictates its very form and existence. The transition between states is not merely a change in appearance, but a structural reorganization governed by the delicate balance of forces that hold our universe together in perfect harmony. From the smallest atom to the largest star, this energy exchange defines the physical reality, creating a world where transformation is the only constant in an ever-changing cosmic landscape. We observe these changes in the kitchen, in the laboratory, and across the vast universe, seeing the same molecular rules applying to a melting ice cube and a dying star. The Plateau Effect serves as a silent witness to the immense energy required for change, reminding us that progress often requires a period of stability before the next transformation begins. Every phase change is a story of energy, a narrative written in the language of atoms, showcasing the resilience and adaptability of matter as it navigates through the cosmic thermal currents. As we look closer at the world, we see the beauty in these invisible transitions, recognizing that the stability we perceive is merely a temporary pause in a larger cycle. The dance continues, fueled by the relentless movement of particles seeking their most stable state, forever bound by the laws that govern the dance of matter in our vast universe.